Thanks for coming, everybody. I'm super excited to be doing this today. It's kind of a dream come true. So a little bit about me. I've been working in Eighth Wall building AR experiences for about 3.5 years now. Before that, I studied virtual reality and augmented reality, kind of working mostly in Unity, building prototypes and games inside of Unity for VR. So I've been working with Eighth Wall on, lots of different AR projects for a while, and I'm really loving the new studio. So yeah, I'm excited, and I want this to be kind of a discussion. If you have any questions, like please feel free to like raise your hand. I'm going to be looking to the left a lot because that's where my screen is with the video on there. But I have my desktop, which I'll share now. This is kind of where I have the game running. So let me just grab that. Let's see. And then, yeah, and if you haven't played Dragon Dash, no worries. I would encourage you to try it. I will walk you through kind of how to find it and where it's at. So it's kind of in two spots right now. If you want to play it, you can go to the homepage and it's just right here up at the front. You can launch it and you can play it on your desktop or mobile phone. It works on both. Personally, I think it's a little bit more fun on mobile phone because, that's kind of what Flappy Bird is. It was a mobile game, and but it works on desktop as well, and you can actually use the space bar. So a little bit of inspiration behind Dragon Dash. I remember when the first iPhone came out. I was in middle school, so I'm dating myself a little bit, but I was sitting in the back of my band class, and one of my friends pulled out the very first version of the iPhone, and he already had some games on it, and immediately I knew I was hooked at that point. So I've spent a lot of time playing mobile games, and mobile games actually inspire, I would say, 90% of the projects that I build right now, either mobile games or mini games from games like Fusion Frenzy, games like Mario Party, a lot of those like, or WarioWare even, a lot of those like small mini game style games really inspire what I like to build. Because I feel like the web, you're kind of limited in what you can do a lot of times. So having a good like base of a very simple game on systems that were very simplified kind of give you a really good starting point. So, but yeah, if you want to clone the project, you can go into this right here and then hit clone project on the right, or you can go into the project library and it should be up here, up at the top left corner, and you can clone it in here too. So those are kind of two options for it. I'm going to clone it along with you guys. I'm just going to call it, let's see, clone one. I don't think we have one yet. Okay. And then as it's creating, I actually wanted to show you guys where the documentation is. It's kind of something that I usually don't start in documentation when I'm building a project, but it's good to know where the reference is. I actually have pretty much made my whole career from reverse engineering sample projects. So I'm a huge believer of taking sample projects, looking at how they're built. They're made by a lot of different individuals, and but most of the time they are kind of the best practices of how to do different things inside of the tool that you're using. So with Studio, I, like Pablo said, went in and cloned the physics project to kind of just play around with physics. And when I felt how the physics were working, it made me want to make a physics-based game. I don't know if many of you have built games with physics on the web before, but it's been a painful system to use. There's not a lot of good libraries for it. It's pretty inconsistent, and it's not a very easy thing to do. So with Studio, once I figured out how easy physics were, I knew I wanted to do it. And in the documentation, this is kind of where the physics are, just kind of for a place for you to look. But I wanted to start off. Nobody's really talked about kind of the basic concepts of building a game in Studio if you're going to be scripting a lot. Studio uses an entity component system. So entities are kind of like your base unit. If you think of, oh, I spelled clone wrong. I just realized that. If you if you think of an entity or like a base unit, think of like a person. So one entity would be like one person. And then you have the components, which are the characteristics of an entity. So they're the different attributes that make up a different entity. If you think of it as a person, you could say like my components are I have blonde hair, I have blue eyes, I weigh, 200 pounds and I'm 5'10", and like those are all different things that make up me. So every entity inside of Studio are made up of different components. And when you're writing code, you're building custom components. So each one of the components that I created in this are custom written code, and that's kind of the basis for the entire structure of it. It's very similar to a lot of other game engines, but it's not exactly the same. So that's just something to be aware of. But I kind of want to show you guys at first glance, like what studio or not what studio, what Dragon Dash looks like in the studio. So it's a lot different than a lot of people think. Anytime I show anybody this project, they're amazed at kind of what it looks like behind the scenes. So it is a 3D engine. We're using 3D objects, and there's a little bit of parallaxing going on. So there you have to kind of set things up in a weird way so that it looks good on camera. So it looks kind of funky right here, but if we play the game, which let me mute my screen really fast because I forgot to do that, and it's going to destroy everybody's ears if I don't. Let's see. Figure out how to do this. Here, let me reshare it without the mute. This game can be kind of loud, so okay, it should be without any audio now. So let's play the game. Um, can you guys hear it? Okay, perfect.
No.
So yeah, you can see kind of the objects moving in the game in the studio, which is on this left side, and then this is what the camera is seeing on the right side. So that's kind of how it looks. Like Pablo said, it is a little bit difficult. I built it once before and it was too easy. I don't know how familiar you guys are with the original Flappy Bird, but people were breaking their phones because they're getting so mad at the game. And to have a game that gets that much of a reaction from people is kind of fun. So I wanted to try and recreate that to the best of my ability. But I wanted to show you guys how to kind of customize that difficulty. We're gonna jump into one of the or a couple of the components here just to kind of do a very, very basic like customization of the game. So we have our different controllers here in the scene. Um, and I kind of built it so each one of these components, or sorry, each one of these entities has a custom component. So if you look, we have the character container, and the character container has the character controller. So this is the custom component that's controlling the character. If we look at the game, we have the jump force, which is the force being pushed up when the character is jumping, and then we have the gravity factor. If you think of gravity, normal gravity is like a factor of 9.8 in physics. When we use gravity factor in this, we're actually multiplying the gravity by our factor here. So it's 9.8 times 8. So this is like 8 times stronger than our gravity on Earth, if you think about it. So essentially, we made Flappy Bird on a different planet, and well, he's a dragon in this one because dragons are a lot cooler. But let's look at this. If we wanted to change how difficult the game is, one of the first things that you can do is actually change the gravity factor back and decrease the force. So we can make this to like 7 and then our gravity factor to 1. Then we want to build the project to get those changes. And then once that refreshes, we'll see how much easier the game is to play. There you go. Oh, and there's a little bit of a bug, but you can see he's moving way slower up and down, and he's jumping a lot less. So you give the user a lot more control. But I mean, it can be a little bit more difficult if you have if you have to like get down fast, because there's a lot of variability in height as well. So another thing that we can control is how fast the obstacles are moving. So we can go in here and change the obstacle move speed. This is on the obstacle container. So we can change this to like 2, build it again, and this will make the obstacles move a lot slower, and it gives you more time to think about jumping. So you can see in the editor on the left how slowly those obstacles are coming. We're not going to see them for a little bit because they're kind of far away, but they're very, very, very slowly coming towards the camera. So now we made baby mode. Um, Not difficult at all. Even I could score in the hundreds, and I'm not really even good at this game, and I made it. So, uh, oh, and then I crashed and restarted the game. But you get the idea. There's a lot of ways that we can customize this just from the editor itself. Um, One other way that we could customize this is if we wanted less variability in the height of the obstacles. So right now there's kind of 12 different points. If you think about the difference between 5 and -6, there's 12 values there where the obstacles can be. If we wanted to make that even less, we could go from 0 to 2. Oh, not 72 to 2, and then rebuild it. And it would give us a lot less variability in the height of the obstacles. That's another way to kind of to scale the difficulty of this game. So we'll look at this really fast. And then if anybody has any questions, just kind of about this brief overview of how the game works, please let me know and I'll answer whatever questions you have. So I have the values of the starting castle hard coded just because that was the easiest way. But now when we restart the game, they respawn themselves in a new pattern that is a lot easier and follows the parameters that we've put on them. So now you can see there's like very low variability between the heights of the different obstacles here. So yeah, now we have very much baby mode. I think my 1.5-year-old daughter could probably play this game and probably get a pretty good high score. But yeah, does anybody have any questions just about some of these brief things that we covered at the beginning?
Yeah,
Please
we
let me
have
know.
a question from Matt, which is actually jumping a little ahead to what you're going to explain soon, but love to get the answer. Is does the application automatically handle the collision detection?
Yeah, for sure. We can look at actually colliders now is probably a good thing to look at. So this game is using the physics system. To be able to create a physics element inside of Studio, you need to add a collider. And I've done this in 2 different ways in this project. You can add a collider directly to an entity. Um, but I kind of do it a little bit different in here. I have the character controller, and this has the physics collider on there. And then inside of it, I have the mesh, which is the actual physical 3D model, so that we're controlling the physics collider, and then the mesh is its own thing. And I did that because I didn't want the user to be limited in the mesh. I wanted them to be able to swap out the mesh super easily and not have the game break per se. Sometimes if you swap out models, it can break things really easily. So I actually started before I added in any of the cool design or anything. These were all just squares and rectangles and circles. So the dragon was a circle forever, and I just used a circular or a spherical mesh inside of this. Um, but yeah, in this one, you can see you have the physics collider, which is the mesh itself that is detecting collisions. And then on the obstacles, we can look at these now. These ones are a little bit more complicated. Um, you can see that they have less uniform shapes for the most part. So we have the first obstacle right here. Let me scroll over to it. There we go. And pan. So if we look at the first bottom obstacle right here, here's the tower. You can look here. I have the mesh, which is the 3D object on the bottom obstacle, but then I have colliders nested inside of the mesh. And that was so I could add a ton of different colliders to kind of give it a more custom shape without using a very, very demanding collider that would kind of morph itself to the shape of the target. That kind of weighs down on the system. If you're using a lot of very, very detailed meshes to create colliders, it makes it so the game runs a little bit slower and there's more for it to process. So I have, instead of having one giant mesh that has a lot of little details in it, I have a couple of different colliders here. I have 5 smaller box colliders, and each one of them just has 6 sides. So it's a little bit more performant for the game to run. But I positioned these colliders along the bottom here so that if the bird collides with any of these little boxes that are set up, the game ends. So yes, there are ways for you to do collisions. And the collisions are kind of handled automatically, but you have to actually write in code what happens when things collide. So now if we want to, I think, does anybody else have any more questions about colliders at all? Are we clear as mud on that one? Okay. Yeah, let's jump into one of these scripts right here. So why don't we start with the character controller, which is kind of the thing that's doing a lot of the heavy lifting on this project. You can see some of the values, and let me pull up the character entity with all of its components, which is right here. So we have our character controller, and then we have our jump force, which you can see translates directly here to this schema. So I guess in the code, there are some base functions that you can use. Let me pull down our documentation again. If we go to this components and custom components, it'll kind of tell you about the component setup, how these different values are set. So what we're talking about right now is the schema. The schema is kind of like a list of different values that you want to get, but you want to be able to get the user's input when they're writing or when they're building it in the game. So anything that's in your schema is going to show up in your component in this window right here. So jump force is one of the ones I wanted people to have more control over. I gave it a default value of 28. You don't have to give things a default value, but it's probably recommended for most of the like values that are numbers or letters. Characters, these entities themselves, there's not really a way to grab just an entity very well. So I always put all of the entities that I'm going to be using in my script in the schema so I can control them here. So you have my character, and then this is just the character right here that we're grabbing this character from. And I went through and added in a lot of comments. There's probably too many comments in my code, honestly, but I figured it's easier for people to understand if there's more than less. And then I did a README that kind of does an overview of each one of these different scripts. So you can go in and kind of dissect these anytime and feel free to clone them and take them and use them in different projects. That's what I always do. But yeah, hopefully it helps you build whatever you want to build. But just and then so we have our schema defaults. We have what is called a state machine. If you're a programmer, you kind of know what a state machine is, but essentially your entity can only be in one state. I guess your component can only be in one state at a time. Um, so that kind of handles like if the game is playing, then we're in game mode. If we're at the start screen, it's in start mode and the game hasn't actually started yet. And then if we die, we're in dead mode. Um, that changes a couple of things. So one of the things, if you notice when we start the game, the dragon, let's pull this over a little bit. He's floating. He's not being affected by gravity at all. And that's because our initial gravity that we're setting, our initial gravity factor that we're giving it is 0. So at the beginning of the project, if we look at the actual physics collider right here, our gravity factor is 0. It's not being affected by gravity at all. It's essentially just going to sit there unless there's a force that's acting upon it. But once we start the game, it changes from the start initial state to the in-game state. And when we enter the in-game state, we're setting the gravity factor with whatever the user defined as the gravity factor. So now we're setting it to 1. And then if we play the game, we change from 0 gravity factor to 1 gravity factor. And that's why he's now being affected by gravity. Also, you can see whenever we're clicking on the screen, there is the force being applied upwards. I used a linear velocity. So there's kind of two different forces that you can apply to a shape. There's a push, which is like if you think about it, you're pushing something really rapidly. Um, and if you're pushing something that's already going up, you're just adding more velocity to it. So let's say you have a velocity of 3 and you're pushing it 6, then you're going to have a velocity of 9. Whereas with set linear velocity, you're setting a constant value for the upward force. So every time you click on the screen, it's changing its upward velocity to 7. It's not adding more, it's setting it to a constant. And that's kind of what we want for Dragon Dash. Different games call for different things, but for this one specifically, I wanted it to be the same, consistent every single time you clicked on the screen. So, and then yeah, there are a couple different things happening. When you tap on the screen, or in the enter of this one, so when we change the state, it's setting up the tap on the screen functionality. When we leave the state on exit, um, we're going to destroy that functionality. And then in game, or that's right here. So on exit of the game, we're going to remove the listener for jump because we don't want that to be listening for it anymore. And then when we're in dead mode, he's going to do his dead animation. So if we can see his little bonk. Um, Here, I need to speed up these obstacles because they're going way slow right now. Just change it to 12 for just demo purposes. But if he bonks on the obstacle, then it plays his death animation. We can see that now. Bonk. So then he plays his death, and then he falls to the bottom of the screen. So that's kind of how this player character script is going. Do we have any questions about this script specifically? No? Cool. If I'm going too fast, let me know. If I'm kind of covering a lot of different things, let me know. I want this to be beneficial for all of you guys. So please like give me any feedback or anything as we're going through this.
Thanks, Declan.
Um,
We had a
yeah,
follow-up question in the Q&A
for sure.
asking, how do you actually change the objects that the dragon is trying to get through?
Um,
Like,
oh, okay, the 3D models themselves. Cool.
exactly, yeah.
Yeah. So to change a mesh, so the 3D model, I guess, we're referencing to it as a mesh. A mesh is just kind of the terminology for a shape in 3D. If we wanted to change the dragon, so let's close this. If we wanted to change him to not be the actual guy anymore, we could go in to this mesh right here. So we're on the character entity. We're now on the mesh component. We could go in and change it to box, or we could change it to plane, or cylinder. Um, oh, so right now I'm going to keep it as the dragon, but you can also see the other models that you import in. These are visible right here as well. So we have our other files, our cloud, we have our tower, we have our wall. You can just swap those out right here. It's very, very easy to change those. And then kind of what you're going to want to do is you're just going to go into your collider afterwards and then readjust the size of the collider. So if we look at the dragon, this red box right here is the physics collider. We could change it to a width of like 12 if we wanted to, and now it's giant, and anything that interacts with that collider is going to um, trigger the script that's running it. But hopefully I changed that back. Yeah, so now it's 0.7 again. So you just kind of want to fit it tight to the body of the 3D model, but it doesn't have to be exact. Again, I don't use a lot of like very exact sized colliders because it's very, very heavy on the performance of the game. So yeah, that was a good question. Um,
Where did you get your assets? That's George is asking for that.
Yeah, for sure. I use a couple different free tools. I always look for Creative Commons Zero, which means that it's a free license to use anytime that you want. Um, my favorite tools are, let me see. We have, oh, okay. Polydot Pizza, I guess, is one that's really, really good. And then Kenny.nl, I believe. Let me see, is another one that's really good. Both of those, Kenny.nl is made by one person. So he just makes everything and then licenses it out for Creative Commons Zero, and it's all free. And then Pizza is another place that has free assets. They're made by a lot of different people and they have different Creative Commons rights to them. So I always look for the ones that are Creative Commons Zero. That way, like if you are creating a sample project like this, you don't have any like legal problems with attribution or anything like that for the artist that's creating these pieces. And then the background piece, I honestly went in and worked with Chat GPT a little bit and used Dolly to come up with a concept and just played around with that. And that's a really good way to find inspiration for these types of styles and types of projects going in. And I use it to come up with inspiration most of the time, but then try and find like actual artists to collaborate with. So. Yeah, and I did have somebody help me retexture this dragon, just because I didn't like the way that it looked originally. So I had a 3D artist jump on and help me make it look better for this application. But cool. Any other questions? Okay. Well, then let's look at actually one of the collider scripts because we want to see how when you make a collision, how do we call those collisions? If we go into our score collider, so we have inside of our obstacle containers, we have the top obstacle, the bottom obstacle, and then a score collider for each one of these different obstacles that are running through. So this is how we're triggering if you score a point or not. If the person interacts with this collider right here, then they're going to get a point for going through the center of the game. Um, this on the right side is our score collider. So we have this this is the event that we're looking for. It's the entity component system dot physics dot collision start event. And then we're looking to make sure that the object that this is colliding with is the same as the character. So I just want to make sure that's clear. What we're doing is we have our collider here. Um, we're getting a notification, kind of. We're getting an event being called whenever this collider interacts with another collider, whenever the colliders touch each other for the first time. Our event is going to return information about that collision, and then data, and then other. Other is going to return the ID of the entity that is interacting with the collider that we're on right now. So whatever component this is attached to. Um, and you can see this is the component right here. So we have our character controller, which is where the mesh of the characters is in this character container. So we grabbed this model or this entity right here, and then we have our game manager, which we'll talk about a little bit after this. But yeah, when we are in this state, we're looking for collisions. And then whenever the character container, specifically that mesh, interacts with our point mesh, then we're going to dispatch an event to add a point to our game. So that's kind of how that's working. This is a very, very specific case of like how the collision system works. Again, that is here in the documentation. If we want to look, we can just look at the physics system, and then it has our different on collision events and how to call them. So yeah, just in this physics section, it's the events. And then you can have an event when objects collide with one another, and then when they leave the collision. So Any questions on like the scripting for collisions? No? Perfect. Okay. So then let's look over probably the most complicated um component that we have here, which is the game manager. The character controller is doing a lot of like the visual things, so controlling a lot of the movement of the character. But the game manager itself is the one that's handling a lot of the logic of the game. And you can see we don't have any of the schema in this one at all. We just go into data. So data is kind of like where you can store global variables, things that you want to have access to throughout the entire component. Um, you create a data for it, and then you can access it by calling data, which we're in our state machine, we're doing a data attribute, and then we're calling a cursor to it, which is kind of like saying we're getting a pointer to the information, and then we're able to grab the information and overwrite it. But um, our game manager is where a lot of the like actual processing of the game is going on. So when we're tapping on the screen, this is what is registering the tap, and then we're firing an event saying that you tapped on the screen because there are a couple different things that need to listen for a screen tap. So when you tap on the screen, it's dispatching an event right here, world.events.dispatch, jump. So that's how we are handling the jump call. So we're dispatching an event to an entity, and then on the character container, we jump to the character again. We are doing the um, there we go. We have a world events add listener. So we're listening for that specific jump on world events global ID. So on all of the entities, we're listening for jump, and then we're going to make it jump whenever that happens. And here's our jump function that's actually making the bird jump. So that's kind of how we're dispatching events, and that most of the event dispatching is going on inside of the game manager. So yeah, you can read through that. I use a game manager in almost everything that I build. It's just the easiest way. I want entities and components to be very specific. So like a component should be very specific to the thing that it's on. You can use components on multiple entities. So if you look here in our obstacle container, I have the, let's see, our, our game over collider is on every single one of the bottom obstacle colliders. Here, let me get a drink real fast. Um, so we have one component on every single one of these entities right here. So they can be reused. You want to make sure that your components are reusable in your project. I'm not used to talking this much. um, okay. The next thing that we want to cover is kind of the tick functionality of our game. Sorry, man. I got a frog in my throat. Okay. So if you've built a game before, you kind of know what tick is. Tick is something that's happening like every single frame of our game. It's something that is constantly going on. So we want to have information inside of tick if we're going to be doing things like throughout the entire process of the game. Um, one of those things is the background is moving constantly. So to do that, we're actually changing the position of the background on tick. If we look in here, if our game is active, we're grabbing the value of the position of the obstacles, and then we're actually moving it by the obstacle speed times delta. And what delta is um, because you have like a different rate that your computer's running at, your frames per second, we want to make sure that we're calculating for the drops in frames. So tick runs on every single frame, but sometimes you might have more frames per second than others. So what we're trying to do is compensate for the difference. That way we're getting like a consistent value. So um yeah, we're using world.time.delta times our movement speed to then determine how far the object needs to move in the next frame. And that's why we're able to get this like smooth looking movement in this game. If we look here. So this foreground element and this background element, they're both being run by a tick. So you can look and see how smooth all this is running. And that's being controlled. We're just translating the position of those 3D models on a tick. Does anybody have questions about that? Tick is another thing that's a very, very important concept for developing a game. And if you're going to be building one, most likely you're going to be putting some elements inside of tick. Because it is running on every single frame, it is very demanding. So you want to make sure that you're only running what needs to be run on tick, and you want to try and like limit that to the best of your ability. So what I do a lot is, I mean, I add in booleans to determine if we're going to be going through a process um, or not on tick. Cool. Looks like we don't have any more questions. So I guess the last thing I want to talk about, um, kind of just to yeah, to help out anybody that is trying to build something more complicated. There are a lot of really, really good examples on how to do things in Studio right now. Um, but I think a lot of the times like sample projects can either be too complicated or not complicated enough, and you don't really get a lot of the information that you need. Um, so I wanted to make sure, let's go back to the README again, that you can go in here and you can take anything that you want. Like Pablo said, I used the physics example to build this project. Um, I never start a project from scratch. That's just something about me. I don't ever build anything from scratch. I always have a template that I think will get me at least like 20% of the way there. Um, before I start a project. So feel free to start from Flappy Bird, maybe play around with some of the controls, see what it inspires you to build. If you want to build something with physics, like learning about how the character controller is being done, playing around with some of the physics variables and changing them, and then diving into the physics documentation right here to kind of learn different ways on how to handle physics. Let's say you want to do a game where you're not applying a constant force upwards, you want to add a force up each time you do press the button. Like you'll have to change this to apply force instead of to set a linear velocity. And you'll just kind of have to read through some of the documentation and figure out how to do those different things. But yeah, I think for me, some of my best inspiration comes from work that other people have started and looked at. I remember playing the gravity sample for the first time and seeing how easy it seemed to do gravity in this project, and it made me actually want to try and tackle physics for the first time. Um, which, like I said earlier, physics is not something that's easy to do on the web for the most part. So, and then feel free to like play a lot of games and kind of find something that interests you. Flappy Bird is one of the things that I clone the most often because it did create such like a visceral response in me and in my friends in high school. I had a friend that is one of the few that, smashed his phone because he got so mad at Flappy Bird. We'd all have competitions to see who could score the highest. And he definitely was not doing very good, and he threw it at a wall and it broke his screen and he had to get a new phone. So um I'll remember that forever, and that's one of the reasons why I love building it. It's just a really good way to test out some mechanics, and then once I kind of have things figured out for Flappy Bird, once I understand how tick works in a system, how event listeners handle in a system, how gravity works, then I feel like I can build most any other project that I want to build. I'd recommend finding out what elements are kind of the basics for the game that you want to make. Like if you had to strip down a game to very, very simple elements, um, what are the very, very easy things that you need to make a very basic version of your game? So like if you were doing a first person shooter, like thinking about the character controller and then thinking about when you click on your mouse. Um, all these different things you want to make sure you go in and think about things and then figure out how to build just those very, very core functionalities. And then once you start getting those core things figured out, you can start adding in more complicated features. But like, yeah, I didn't tune any of this game until I kind of had the very basics of it figured out. One of the games I'm working on right now is an infinite runner, kind of like a clone of Subway Surfers and Temple Run. And I'm going through and working on just the movement right now, building out like the simplest thing that I can. And then whenever that gets figured out, I'm going to add in more of like the design. Like, all right, let's add in jumps. Let's add in jump cancels. Let's add in more of these more complicated elements. They're a part of like what we'd consider a modern day infinite runner, but always start with the basics and then you can add on more and more and more as you want, but remember that this is web, so it can't be as complicated as like a console game. So just try and make sure you're recognizing that as you're building it and don't get frustrated. It is a little bit of playing around with it right now and just figuring out how to make it work. But I've gone through and fixed this code a bunch over the last couple weeks, and I believe it to be kind of the standard that they're looking for these types of projects. So if you have questions or anything, please reach out to me. I can help. Um, I do a lot of work through LinkedIn, so please feel free to reach out to me on LinkedIn, message me if you have cloned the project or if you're just kind of looking for like a guide on what you can do to make your dream a reality. If you're running into a wall, maybe coming up with a creative solution how to fix it, please reach out and I'd be glad to help you out and help you, on your game dev journey through Studio because it's something fun that I don't think we've ever really had before, and I'm excited to see what people make.
Yeah. Thank you, Declan, so much. We have a couple of questions coming in, both in the chat and in the Q&A, so I'm just going to try to go through them in chronological order. Matthew's asking, does the camera count as an object and can it be given collision? I'm guessing maybe for like a break the fourth wall type game. That might
Yeah.
be interesting.
So your every single thing here is an entity. So yeah, your camera is an entity, and in theory, yes, you can add a physics collider to it. You could even add gravity to it if you wanted to. So I just did that on my camera right here, where if we want to try and find it, here's our camera. And then you can see, let's see if we can see the physics collider. There's our box physics collider right now on top of our camera. So now our camera does have a collider on it, and you can, in theory, do that. Um, Sounds like a fun idea. I've never done anything like that before.
Yeah, definitely interesting. Dizzy simulator. Yeah, Jared. There was a question about a joystick controller. Any recommendations on how to develop something like that?
So I've not done anything like that yet, but that sounds like a really good use for this input manager. So the input manager is something that's really cool. You can read more about it in your documentation, but you can add bindings to different things. So I have this jump input right now. I can add a binding, select the input, and we can go to gamepad and we can have like an actual game joystick. Um, if we wanted to use a gamepad, you can add in your mouse and keyboard um, controls as well. I've not built a joystick for the mobile device though, so I'm not 100% sure how to approach that right now, or I don't really know if there's a sample of that yet, but I'm sure it's something that can be done. So,
Yeah, the Bunny Blitz game, the sample project has character controllers where you can click and drag the character. It's not necessarily a joystick, but that might be a good place for you to start looking into. We have another question here. Is there a way to keep movement of the background image rather than static?
Oh, and
Um,
this, good
yeah,
question. So yeah, I mean, you could right now this is just a plane, so a flat 3D object. Let me find it. Background. There we go. So it's a plane with a texture of the image on there. You can use 3JS to change the texture to a video. That is possible. It's a little bit more complicated. I don't think there's an out of the box solution for it yet, just from like the visual elements like this. But you can use 3JS to go in and write a custom component that takes in video and then overlays that as a texture on a plane instead. That's what my recommendation would be. If you wanted to move it, you could move it the same way that we're moving any of these other obstacles by translating it. You could actually go in and create a 3D scene that has real depth and like a whole environment back there and has like clouds that are floating by. And I didn't have the time to do that. So
awesome. Thank you. We have a question from Kyle asking, can this be an AR version of the game? Can the camera kind of show the real world with the objects playing in front of it?
yeah, so that's something I actually have plans to build this into later. I wanted to just make sure that this web version was working really well first. But what I would do, you'll delete the background, and then you'll actually go into your camera right here, and we have our camera. Oh, let me delete that physics collider before we do anything. Um, we have our camera, which is currently 3D only. So it's basically just a camera running like a game on the web. You can change this to a world effect, and it will now turn it into an augmented reality camera. So you'll see, uh, it might not be doing it right now. Oh, since it's on my computer, I have it just running as 3D on my computer. You could change this, disable the computer version of it or whatever. But if you took this onto the phone, it would be an AR. It's not set up to work yet, so there's still some functionality changes I would have to add in to get it to work. But in theory, that is something that can happen. So hopefully in the next month, I will have a my goals are to make a face filter version where when you open your mouth, it tracks to the distance between your lips. So if your mouth is open, then it'll make the bird jump. And then if your mouth is closed, it won't. So it's basically using your mouth opening and closing as the trigger. And then to do a world version that is world tracked.
Awesome, cool. We had another question regarding how would I go about cloning the tutorial examples that no longer offer cloning? Would it just be copying the code over? I think this is a question regarding with non-studio projects
Hmm.
and studio projects. So George, do you want to take that one a little bit here and see if there's a way to answer that?
Can you say the question again?
Yeah, so how would I go about cloning the tutorial examples that no longer offer cloning? Would it just be copying the code over? And I think what they're asking is taking a project that exists in the cloud editor versus moving it to the studio.
Yeah, so it really depends on the project. You're not going to be able to just take a Cloud Editor project and drag it over to Studio and it works. Because the Cloud Editor projects, most of them use A-frame or 3JS. So at some point you're going to have to translate that over to the new syntax that's a part of Studio.
Yeah, so
Um,
they just kind of answered a follow-up. Is they're trying to follow the YouTube tutorials, but yeah, those are all cloud editor
yeah,
sample projects. And just a reminder that if you're on an eighth wall free account, you do not have access to those cloud editor experiences. So you have to upgrade in order to do that.
yeah, we're still working on building out, more tutorials and more resources for Studio, especially as it matures, right? It's still in beta, hasn't hit 1.0 yet. We're still working on it. Um, and with that, there comes these big changes. So it's hard to commit to, putting out a full video tutorial for something that might not exist in a couple weeks.
For sure. Cool. And then Declan, we have a question for you from Justin asking, are there any other known performance bottlenecks or limitations that you face with building?
Um, yeah, I mean, so right now I'm working on a game for the challenge, and it's going to have a lot of particles in it. So just whenever you're spawning in a lot of 3D objects, you're going to run into that. You want to keep your 3D objects as small as you can. I would say if I'm building a 3D model for the web, I'm going to keep it less than like 2.5 megabytes is kind of my maximum that I want to have for a 3D object. Even less than that is good. I think most of these 3D models are in the kilobytes, so they're not even in megs yet. You want to keep your textures as low as you can. That's where a lot of memory can be like used is in the textures. So don't use anything more than 2K. 2K is kind of the maximum that you're going to use for web. Even that is a lot. I think most of these textures are like maybe 540 by 540. Try and keep everything square because if it's not square, it's going to try and convert it to be a square or at least a power of two. So like a 540 by 540 or 540 by 1080. You want it to be a power of two value, the dimensions, because if not, it's going to try and convert it, and that's going to be a lot of the processing power on the loading of the actual application itself. So those are just a couple things I've found working on web-based 3D projects in general. Those are kind of the best practices for those, and that's what I would recommend. And then I guess one thing I will show you guys actually that I should have shown you earlier. Something that is kind of interesting. It's hard to get inputs going for this like screen taps right now. So what I actually did was I added in a plane that doesn't have a mesh that has a collider that's grabbing those interactions. And that's what's being done to get the tap on the screen. So you're tapping on the screen, it's casting a ray, and then it's colliding with this plane right here. And that's giving us our tap functionality.